Hey everyone, and welcome. If you're a creator, a developer, a builder of any kind, sooner or later, you're going to hit this crossroads. How do you actually structure the data that makes your project come alive? Today, we're jumping into the Builder's Guide to Databases, getting right into the core of SQL versus NoSQL. So let's open up that toolbox and get our hands dirty. All right, so let's boil this whole thing down to one critical question. Your project needs a home for its data. What kind of foundation are you going to build? Are you going for something super rigid and predictable, or do you need something more flexible and able to adapt on the fly? And that choice, well, it's going to shape your entire project. First up, we've got the classic, the OG, the time-tested standard, SQL. I want you to think of SQL as the meticulously engineered blueprint for a skyscraper. It's all about order, consistency, precision. When you just can't have things go wrong, this is your go-to foundation. So, at its core, SQL is literally the language we use to talk to these things called relational databases. It's the universal standard for managing data that fits neatly into tables, with nice, clean rows and columns. And look, there's a reason it's been the king for decades. It just works. It's incredibly reliable.
So, when do you reach for SQL? Well, you pick it when your data has really clear, predictable relationships. Think about a customer and all their past orders. It's absolutely crucial for something called ACID transactions. The easiest example is a bank transfer. The money has to leave one account and arrive in the other. It's all or nothing. There's no in between. And that's how you guarantee your data stays clean and correct every single time.
And this quote just nails it, right? For things like customer records or financial systems, that rigid structure, it's not a bug, it's a feature. It's the very thing that guarantees everything is consistent and protects you from data getting messed up when accuracy is everything. But what if your data doesn't fit into those neat little boxes? What if your project needs to change and evolve? Well, for that, we need a totally different way of thinking. We need to talk about NoSQL. It's less like that rigid skyscraper blueprint and more like a flexible plan for a cool modular home. And a perfect example of this philosophy is MongoDB. So MongoDB kind of throws the old rulebook out the window. Instead of those rigid tables, it stores data in these super flexible JSON-like documents. This whole approach was built from the ground up for high performance, and this is a big one, for making developers' lives easier when the data structure isn't set in stone. And this is built for the messy, wild world of modern apps. Think about it. User-generated content, social media feeds, data from thousands of IoT devices. The data is often kind of messy, the structure changes all the time, and it grows unbelievably fast. That is the world MongoDB was made for. Okay, check out this real-world story, because it's perfect. Imagine an e-commerce site. A t-shirt has a size and a color, but a laptop has a processor type and amount of RAM. You can't just cram all that into one rigid table without it getting super messy. MongoDB's flexibility means every product can have its own unique set of details, and that is a massive, massive advantage. Okay, so we've got structure with SQL and we've got flexibility with MongoDB. But what if your number one, top of the list, absolute priority is just raw, unadulterated speed at a massive scale? For that, we need another flavor of NoSQL. We need a high-performance engine. We need to talk about DynamoDB. DynamoDB is a different beast altogether. It's a fully managed, serverless database from AWS, and its whole reason for existing is to give you crazy fast, single-digit millisecond performance, no matter how huge your application gets. We're talking blink of an eye fast. Speed is its one and only mission. So what's the trade-off for all that speed? Well, DynamoDB is built for simple, direct lookups. You can't really ask it complicated questions that involve linking a bunch of different tables together like you would in SQL. But by keeping it simple, it delivers that insane performance. Think about a global gaming leaderboard or an online shopping cart during a flash sale. You need instantaneous updates, and that is DynamoDB's sweet spot. And let's just stop here for a second. Read that. Zero maintenance. Because it's serverless and it auto-scales, you don't manage any servers, you don't provision anything, you just focus on building your app, and DynamoDB handles all the complexity behind the scenes. For a developer, that is an absolute game changer. So, we've seen the structured foundation, the flexible blueprint, and the high-speed engine. Now, let's pull it all together, lay out the complete toolkit, and help you figure out how to make the right call for your next big thing. This table really lays it all out. You can see the trade-offs right here. If you need that rock-solid data integrity, you go with SQL's relational tables. If you need the flexibility for something like an e-commerce site, MongoDB's document model is your best bet. And if you need that insane speed for real-time gaming, DynamoDB's key-value model is the way to go. You see, it's never about which one is best. It's always about which one is the right tool for the job you have in front of you. And that brings us right back where we started. We've looked at the blueprints, we've looked at the engines. The choice of foundation depends entirely on what it is you're trying to create. Do you need structure, flexibility, or pure speed? The right tool is in your hands. So the only question left is, what will you build?